welcome you to this material science class. And today we are going to learn about the today's theory and Sommerfeld's theory about the conduction of electricity. The electricity conduction takes place due to movement of free electrons through the particular conducting medium. Every atom has a proton, which is positive charge, and neutron, which are taking place in the nucleus, and negative charge electrons are revolving around the nucleus. So these negative charge electrons possess different energy levels. The electron which moves in the outermost orbit has less energy. So due to less energy, sometimes it may move out of the orbit. In this case, it's called as free electron. And whenever the certain potential is applied, voltage is applied from battery or whatever the source may be, then the negative charge free electrons may be attracted towards the positive terminal of the battery or positive lead. So due to this attraction, the negative charge electrons are moving. Due to this motion, in the opposite direction, some effect takes place, which is called as electric current. It depends upon the charge of the moving particles, how many electrons are moving, and therefore the total charge moving through this medium, conducting medium, depends upon the number of electrons. So whenever the electrons are moving, electric conduction takes place. So this was explained by the scientist Drude, but he could not answer a question. Whenever the free electrons are moving through a conductor, the electrons cannot escape out of the medium. The electrons cannot escape out of the conductor. These electrons are not moving out of the conductor. So why? What is the reason for it? It could not be answered by Drude. So that is the drawback. And another scientist called Sommerfeld, he has answered this one. He has explained the same way as Drude explained. The electric conduction takes place due to movement of free electrons, and the free electrons do not move out of the limits or the boundary of the conductor because some constant voltage is applied. Whenever the voltage is applied, the electrons are moving. So whenever the constant voltage is maintained across the conductor, the free electrons are not moving out of the boundary of the conductor. They are moving towards positive terminal. So in this way, Sommerfeld explains, it's called Sommerfeld's theory. The initial one was Drude's theory. The next one is Sommerfeld's theory. So he has calculated the energy also. The energy by which the electrons are moved, that's E is equal to h square by 2m into into lambda square. Lambda is the wavelength in which the electrons are moving. The electrons are moving not in a straight way, but he has explained that it moves in curved form. Therefore, the wavelength of this movement of electrons, that's equal to lambda. Lambda is also equal to 2 pi by k, where k is wave number. And there was some difference between conductors, insulators, and semiconductors. Conductors, the material that conducts electricity. The materials which do not conduct electricity, they are called as insulator, like rubber, wood, and so on. Some materials they do not conduct electricity, but whenever some external energy is applied, they start conduction. It's called semiconductor, germanium, silicon, and so on. So in the conductor, the energy level is explained by some energy band diagram. So the conduction band, that is the energy level for conduction free electrons. The valence band is the energy level that represents the energy of the electrons in the outermost orbit. There may be difference between these two. That's called as energy gap. In the case of conductors, there's no energy gap. Both conduction band and valence band, they overlap each other. So conduction easily takes place. The electrons in the valence energy level is easily transformed into conduction state because of the conduction energy level is same. But in the case of insulators, there's a large gap between the conduction energy and valence energy. So the electrons in the free outermost orbit could not be moved to conduction states because of large energy level. And the energy level is very small in the case of insulators, about 1 electron volt. Electron volt is the unit for this energy level. So the energy level, whenever the external energy is applied, when this energy level overcomes this energy gap, it means it starts conduction. The electrons in the valence energy level is transformed into conduction energy level. So this way, the conduction and these things are explained by band, which is band diagram. It's called band theory. And also the energy level that depends upon a constant k. The energy level is given by h square by 2m k square. H is the Planck's constant. M is mass of electron. Whenever k varies, the energy level E varies. That's represented by parabolic representation. I have given this one in the notes. Read these things. So the beryllium has classified into different zones according to variation of the value of the constant K. The constant K that's obtained from the 2D is equal to sin 2D sin theta is equal to n lambda. It's called Bragg's law. Whenever light ray falls to a particular conductor, it may be reflected back at various atomic planes. The energy, there is spacing between the two atomic planes, that's reckless d. That's called interplanar spacing. So Bragg has explained the reflection, and he has given a law. This is called 2D sin theta is equal to n lambda, and 2D sin theta is equal to n lambda, and lambda is the wave number of the ray which falls over the conductor, and he has calculated the value of k by introducing value of n lambda as 2 pi by k, and he has calculated the value for k, and when k varies, the different zones are pointed out by the scientist brilliance. It's called brilliant zones. It may be represented in single dimension or 2 dimension or 3 dimension. It's called brilliant zones. And the number of energy states per unit volume of the material, that is called as energy density. The energy density may be varying according to the orbit of electrons which are revolving in the atom, and it can be classified into different zones: conduction zone, valence zone. There will be gap between these two for the insulator, and these two zones may be overlapping. In the case of conductor, there may be small gap for insulator. In this way, the zone theory is explained. These are the most important things in atomic energy level. So I given these things in the notes. Just go through it. If you got any doubt, just kindly contact me. Thank you.